Okay, welcome to lesson 8.1. We're looking at the vector and parametric equations of lines in two space. This is our first lesson on lines. The next two lessons will be on the equations of lines in three space, and then the last lesson, there's only 4 lessons for this chapter, the last lesson will be all the different equations for planes. So in this lesson, we're going to define a direction vector. Every line has a direction vector, and it's a non-zero vector. We're going to call it M, similarly how we called slope M in grade 9. The M vector, the direction vector, is A comma B, and it's going to be collinear to the given line. So remember that word collinear means parallel. And it's similar to a position vector, except that here the original thing is a line, not a vector. So a direction vector would just be in the same, would be collinear to a position vector, but here we're talking about a line, not a vector. The x and the y components, the a and the b, are called the direction numbers, so I may reference that in the textbook. So for the first example, we're just going to take a look at how do I draw a line if I'm given the direction vector and a point on the line. So I have a point 4, 1, so I'm just going to add that to my grid. There's my point P. And I have a direction vector at -2 and 3. So there is my direction vector. Oops. Going out to -2, 3. And now I'm going to draw the line. And I've already I can see what it's going to look like here based on that direction vector. So this guy here is my M. And now I can find other points on the line using that same direction. And I can see here, it's like backwards 2 and up 3. This is kind of like slope, right? And then going forward, I can do the same thing, but going down. And then I can draw my line. My line goes on forever in both directions, so it should have arrows on both ends. So I'll make that nice and clear. And so this is the line that I was actually looking for here. All right, example 2. If a line passes through A, -1, 2, and B, 4, 3, determine a direction vector for this line. So in order to find a direction vector, we can use the vector that connects these 2 points. Right? So it's like I've got this, I'm going to just draw a quick sketch here. Oh, that's terrible. So just a quick sketch of what's going on here. I've got these 2 points. A is over here, -1 up 2, and B is over here, 4 and up 3. So here's my AB. I've got the line that connects these guys, right? That's what they're giving me in the question. So it's this line that goes on forever through these 2 points. And what I want to know is what is a direction vector for this. So if I take this line from A to B and I just drag its tail to the origin and I figure out what this vector is, that would be a direction vector. Hopefully you can see that there's multiple direction vectors for any given line because they can have different magnitudes, or they could go in the opposite direction. So it's just a vector that's parallel to the line. So one possible direction vector is A to B. So we're going to figure that out, and remember to do that, I take the B coordinates and I subtract the A coordinates, or you can do that within one like this. And so I end up here with 5, 1. Oh, sorry, that's a bracket. And again, we're just in 2 space for today's lesson. So this is one possible direction vector. Another possible direction vector that somebody could come up with is double this one, or triple this one, or half of this one, right? They could come up with anything. One of the others that most people might come up with is I could have used B to A. And so that's just subtracting the points in the opposite order, and I would end up with -5, -1 if I did that, okay? So that's just a second option. You don't have to give 2 options though, because they ask for a direction vector. All right, so equations of a line. Now that we know about direction vectors, there's two ways we're going to talk about equations of a line in R2. So we're talking about two-dimensional space here. The first one is to say that R, so this is going to define the vectors for my line, is equal to R naught plus T, plus T times the direction vector. And I'm going to define here that T belongs to the set of real numbers. So T is just a scalar multiple in front of my direction vector. And I've defined all these guys down here. So remember that R naught is going to be a vector that goes from 0, 0 to a point on the line. So what's going to show up here, the x naught, y naught, is going to be the head of the vector. But this is a point on my line. Now, in order to figure out any given points, right, so I'm going to have some point on the line plus t times the direction vector. In order to figure out any point on the line, I can just replace the t with a number, any number that belongs to the set of real numbers, and I'll find a point on the line. So I'm keeping that in mind here. When you state the equation of a line, notice that it does include defining the parameter as belonging to the set of real numbers. That is part of the equation. Another way that we can define equations is by using the parametric. And what that means is just taking this guy and separating out the x and the y coordinates. So remember from this right here, what I would get is that r is equal to, remember that r naught is going to be x naught, y naught, plus t times my direction vector, which is a comma b. Right? So that's what I'm going to get here. And this direction vector r is going to be some x, y coordinate combination. Now I could use my component arithmetic and expand the t into this bracket, and then I can add the matching coordinates. And what I would get then is x naught plus t times a, comma, y naught plus t times b. And you'll notice this is the parametric equation. We're saying that the x coordinate is equal to x naught plus ta, and that's exactly what we have here, right? So it's just the kind of like the expansion of the vector equation. They're very much related. And then similarly for the y coordinate, y naught plus tb, and that's what I see up here, okay? So let's do a couple of examples. In example 3 here, we're going to determine the vector and the parametric equations of a line passing through the point B is given to us with the direction vector m. So I want to come up with two equations. I'm going to come up with the vector equation so I know that that looks like r is equal to r naught, the r naught vector, plus t times my direction vector, where t is some parameter belonging to the set of real numbers. And so now I'm going to fill in what I know here. I've got r naught, that's just a point on the line, and I have a point here, so negative 2, 3, plus t times my direction vector. And I've got my direction vector here, 1, negative 4. And again, I'll state that t belongs to the set of real numbers. And that would be my answer. Normally I wouldn't write out the basic one above it. I'd just dive right in. So that's my answer there for the vector equation. Next, they're asking me for the parametric equation, right? They asked for both. I'm going to label it so that my teacher knows that I know the difference. And so for this one here, we're going to have x is equal to something and y is equal to something. And really, it's just expanding this out, right? So it's going to be negative 2 plus 1t for the x coordinate. And then it's going to be 3 minus 4t for the y coordinate. And again, for the parametric equation, I need to define the fact that t belongs to the set of real numbers. And so this whole thing here would be my parametric equation. All right, part B says sketch the line. and determine the coordinates of 4 points on the line. So I've got my point -2, 3. There's my point B. And I've got the direction vector. The direction vector goes over to 1 and down to -4. That's where the head of the vector would be. So I'm going to draw that in. And that's going to help me find some more points on my line because I'm going to follow this exact same pattern from the point that they gave me. So there's going to be a point here, here, and then I can repeat the pattern backward as well. And then I'll connect those guys. Mine's a little askew here. You'll line it up with your ruler. And then of course my line has big old arrows because it extends forever in both directions. So I want to know that you know that, especially now that we've got vectors in the game as well. And so this is the line that we're talking about. This is my my line. I'm not going to use a vector notation. I'm just going to say that this is the line. Okay. The other part of part B asked me to find the coordinates of 4 points on the line. So hopefully you can see some of those points really clearly. When we don't have a graph, I'm going to show you how you would do it. To find any point on the line, I'm just going to pick a number for t. So all I have to do is pick 4 different numbers and it's going to come up with 4 different points for me. So for instance, I might pick t = 1. And then I'm going to figure out that x, y, so that's my r vector, would be equal to, and I'm just subbing this in. You can either sub in the t = 1 here, and you're adding then -2 + 1 and 3 - 4. Or you could have subbed the t in over here, right? And then you would have gotten -2 + 1 and 3 - 4. It doesn't really matter which one you're looking at if you have both. And then I'll just keep going. I'm just going to pick 4 different numbers. So maybe I pick t = -1. And then the point would be, so again, I'm plugging it in. I'm going to look over here for this one. So -2 - 1, so I get -3. And then 3, and then this would become +4, so 7. And hopefully this kind of checks out with your graph, right? So -3 up to 7, that checks out. And -1, -1. Since I have the graph, I'm just going to check it out. And then I'm going to pick 2 more numbers. You can pick different numbers if you like. I'm going to pick t = 5. And again, I'm just plugging in. I'm going to multiply this vector by 5. So I'm going to get -2 + 5. And then I'm going to get 3, and I'm going to get -20, so -17. And so I might just check, like, does that make sense? If I go over to 3, that I'd be like way off the graph in the negatives, and yes, it does. And for t equals, and again, you can pick anything you want, maybe like -21, it doesn't matter. This one's not going to be on my grid, but I'll plug -21 in for my t value, and I'm adding -2, so -23. And then if I plug -21 in here altogether, that's going to come out to 87. And there's 4 points on my line. But again, you could choose different t values and get 4 different points. Part C says, is the point Q -10, 31 on this line? So for this one, if -10, 31 is on the line, then the t value will be consistent in the parametric equations. And what that means is it's going to be the same t value for x as it is for y. So we're going to just plug these numbers into our parametric equations right here. So I'm going to plugging them in for the x and the y. I'm going to solve for t, and if I get the same number, then the point's on the line. And if I get 2 different t values, then the point is not on the line. Okay, so we're subbing it in. And then I'm going to solve for t. So here I'm just moving the -2 over and adding it. So I get -8 equals t. I should get -8 over here if the point's on the line. So bringing the 3 over, I get 28. equals negative 4t, and when I divide out that negative 4, I get negative 7. And I got two different t values, and so therefore the point, this was called point Q, therefore the point Q is not on the line. All right, next example we're going to take a look at. Determine the vector and parametric equations for the line containing the points A and B. So for this one here, I don't have a direction vector. I have two different R naughts. So some people are going to use R naught is equal to negative 2, 1, that point there, or some other people are going to use R naught is equal to 6, 5. It does not matter which one you choose. So you get to pick. And when I mark the test, right, everybody's going to have different answers. That's okay. So we've got our R naught, that's part of our vector equation, and now I need my direction vector M. Again, if I'm given 2 points on the line to find my direction vector, the easiest thing for me to do is to connect those 2 points and not worry about magnitude. So you could do A, B, but remember somebody else, or I'm just so used to doing the vector notation, or somebody else might use VA, right? They might do it in the opposite order. It does not matter. So again, that one's a you choose. So this time I'm doing the B values minus the A values. So I've got 6 minus negative 2, and I've got 5 minus 1. And so I end up with 8, 4. Okay, but again, somebody else might have a different direction vector. That's okay. There's more than one vector equation for a line. It's like upsetting, right? Okay, so for my vector equation, I'm going to get R naught, or R is equal to R naught. So I'm going to use the first one, but you could have used the second one, and you're also correct. And then I'm adding T times the direction vector. And again, somebody else might have a different direction vector. You could even do like a scalar multiple of this. Like if it really bothers you that there's like a value you can factor out here, you could use 2, 1. That's also a valid direction vector. And don't forget for your vector equation to tell me that that parameter that you're using belongs to the set of real numbers. And then I'm going to do the parametric equation. And so here I'm just splitting up the x and the y coordinates, because remember that this guy here is just like equal to x and y. This is your actual equation though. I wouldn't normally write x, y. So I'm just thinking about what the x coordinates. So x is equal to negative 2 plus 8t. So I'm just using those guys. And then for the y value, I'm doing 1 plus 4t. Now, in this example, they asked me for both of these equations. Because I've already defined t belonging to the set of real numbers over here, I don't technically have to do it over here. It's the same t, but I just do it out of habit so that I don't forget some other time. If you were given a question that asked you to come up with 2 different equations of a line, so it's for 2 separate lines on the graph that are not the same, you can't use the same parameter. So if I were to now use a whole new point and a whole new different direction vector that goes off in a different direction, I would have to use S belongs to a set of real numbers or something like that. All right, so I've got my 2 different equations, and now part B says, what are the coordinates of the point where this line crosses the x-axis? Okay, so if I'm crossing the x-axis, remember I'm in 2 space here. Then I know that the y value is 0, right? I'm on the x-axis, then there's no height. What I'm looking for is what is this value here. So I'm going to use the variable a. You could use a different variable, it doesn't matter. But here I'm defining for you what I mean by a. So now what I'm going to do is find the t value here that gives me y equals 0. And once I know that t value, I can plug it in here and find the x coordinate. So find t that gives this y coordinate. So I'm just subbing in y equals 0 in my parametric equation and solving for t. So I'm going to bring the 1 over and subtract it, and then I'm going to bring the 4 over and divide it. And so t equals -1/4 will give me my x-intercept. So now I'm going to go and find the x value. I'm using this parametric equation from up here, but now I know that the t value is actually -1/4. And so I can figure that out. 8 times -1/4 is going to give me -2, and I come up with the x-coordinate of -4. All right, equation 5, or example 5, I'm determining the vector equation of a line that is perpendicular to this line and passes through the point C5, -1. Okay, so this is not the line I'm looking for. This is a totally different line. It's actually perpendicular to the line that I'm looking for. So what I know here is the direction vector of the given line. That's always the one with the parameter t, right? So it's m equals 1, 4. If I want, but I want the direction vector of the line I'm actually looking for. So I'm going to name it. I'm going to say let, I can't use m again, so maybe I use n. And I don't know what the coordinates are, so maybe I use a, b. Okay, so we got to find this direction vector. Because I know that the lines are perpendicular, remember back to chapter 7, we know that when two lines are perpendicular, they're, or actually before I get there, sorry, if two lines are perpendicular, the direction vectors are also perpendicular. I can fit it. Okay, so that tells me then that the m vector dotted with the n vector. Remember this from chapter 7? If I take the dot product of two vectors that are perpendicular, I will always get 0. So I'm going to set up here, I've got 1, 4, dotting with a, b. I'm going to get 0. And then for the dot product, I'm just multiplying the x's together. So 1 times a, and then I'm adding, and now I'm dotting, or multiplying the y coordinates together. So 4 times b, and that just equals 0. Remember that for the dot product, I'm getting a scalar, not a vector anymore. So this is just a number. So what I'm looking for then is a pair of numbers a and b that satisfy this equation. So you might isolate so that it's easier, but basically what you're going to do is pick any number you want for b and then calculate the a value. You always start with like the more complicated side, right? Pick that number, and then you can calculate the simple side. So if b is equal to, maybe I pick 1, for instance, it's a nice easy calculation for me, then my a value would be -4. But you could pick any number for b that you wanted. This is one pair of integers that will satisfy the equation. There are an infinite number of pairs, but they do all have the property that they'll be collinear. So what I get then is that my direction vector is, remember I defined it as a, b, so it's the a value, the b value. And then the question asked me to find the vector equation of that line. So I'm going to set that up. It's going to be a point on the line, which they gave me. They said that my line passes through the point C, 5, -1. So 5, -1. And then it's going to be plus the parameter times the direction vector. But the parameter t was already used up in the given equation, so I'm not going to use t again. I'm going to use s, and then I'm going to multiply that by my direction vector. And again, I'm going to define that s belongs to the set of real numbers. And that's it. That's my answer. Have fun with the homework for this section, and I'll see you for the next lesson.